Hello, ladies and gentlemen, and welcome back. Root Beer here with the very last question on the 2008 Cayley contest. We've got question 25. The average value of a minus b squared plus b minus c squared plus c minus d squared plus d minus e squared plus e minus f squared plus f minus g squared over all possible arrangements a, b, c, d, e, f, g of the seven numbers 1, 2, 3, 11, 12, 13, and 14 is... Then we have some numbers that are very close to one another. Alright. So... we could try to compute the actual average. How many rearrangements of A, B, C, D, all through G of them? Well, there's 7 letters. And that is defined as 7 factorial, 7 times 2, 7 times 6 times 5 times 4 times 3 times 2 times 1. That's the number of possible arrangements. Now, this happens to be 5,040. So it's a little big for us to actually work with. Especially because the sums of all these squares is going to be bigger. But if we're smart and if we can reason about it, we might be able to reduce this. Because I don't want... there's no way we can write out all 5,040 possible arrangements of all these these numbers and then take their differences and square them. Now, if you're having trouble with a question like this, I would recommend you try a simpler case. So we might try something like a minus b squared plus b minus c squared. I could actually... and then use, 1... 2, and 5. I don't think the numbers as yet matter particularly, but we'll just pick some small numbers like that. There. Just shutting the window. Okay, so I can actually write out all... there's only going to be 6 possible combinations. 3 things, 3 factorial, 3 times 2 times 1, 6. So there's 6 arrangements. So we could have 1 minus 2 squared plus 2 minus 5 squared. 1 minus 5 squared plus 5 minus 2 squared. 2 minus 1 squared plus 1 minus 5 squared. 2 minus 5 squared plus 5 minus 1 squared. 5 minus 1 squared plus 1 minus 2 squared, and then 5 minus 2 squared plus 2 minus 1 squared. So that'll be 1 plus 9, 16 plus... I don't think the actual values matter, but we might want to verify this later. Or we might want to use this and what we learn and the actual answer we get out down at the end here to test some things later. So 5 minus 2, that's 9. 1 and 16. 3 squared is 9. And another 16. 16 and 1. And 9 and 1 again. Okay. So notice a few things. What we've got here is 1, 9, and 16 all over the place. So we might even ask, well, how many... And so we can actually add these up. There's 10, 25, 17, 25, 17, 10. 2 10s, 2 17s, 2 25s. 10 and 17 is 27, plus 25 is 42, so we're going to have 84. Divide that by 6, and we will have 14. Yes, 14. Okay, now 14. How does this relate to 10, 25, and 17? Well, I think it's just the average. I think it's the average of them, to be honest. Okay. So, what have we got here? 1, 9, and 16. That actually adds up to 26, which sadly does not relate to 14 very easily. But I noticed that there's a 1, a 9, and a 16, and these are the only ones. And that there's 4 16s, there's 4 9s, and there's 4 1s. Okay. So, why is that, we might ask? Okay. So, where can the 1 come from? The 1 can come from the fact that we've got a 1 and a 2 paired together. So if A is 1 and B is 2, or A is 2 and B is 1, we're going to get a 1 there. And there's 2 ways that can happen. Same thing if B and C are 1 and 2 or 2 and 1. Alright. I'd really like to know why it's 4, because then it's just 1 plus 9 plus 16 times 4 divided by 6. Right? Wait, something... Yeah. Times 4 divided by 6. Did I not... Yeah, I added these up right. So how come 26 times 4 divided by 6... 26 isn't a multiple of 3. What did I do wrong? I did something wrong. What did I do wrong? Did I not add this up right? 2 25s is 50. 2 10s is 70. There we go. It's 104. Oh, it's 52. I did 52 times 2. I said 42 times 2, and I did 42 times 2. It's actually 52 times 2 that we want. And this is not a multiple of 6. Doesn't really matter. But, okay, so it's 26 multiplied by 4 divided by 6 is the same thing. Now, divide by 6, we would replace that with divide by the 5,040 ways that we can actually do the A, B, C, D, E, F, G rearrangement. So, what number goes here? What number is replaced by the 26? And, more importantly, what number goes in place of the 4? Why is there a 4 there? Is what we need to ask ourselves. So, it looks like the sum of all possible x minus y squareds multiplied by number of times it appears divided by the number of rearrangements. So the possible x minus y squareds, that would be things like 14 minus 13 squared, and then 14 minus 12 squared, all the way down to 2 minus 1 squared. Okay, so there'll be 21 of these that we actually have to add up, but I can figure that number out. But then, what is the number of times it appears? So, imagine a pair x and y. Imagine a pair x and y. Where does x minus y squared, or when does x minus y squared happen? Well, no. Let's say how many x minus y squareds. So we've got in our big problem we've got a minus b, b minus c, c minus d. It's really curious that there's no g minus a to round things out. There's only 6 sums, whereas you might expect 7. So once I choose a pair x, y, there's 6 squares in our sum. two ways to arrange, because x minus y squared is the same as y minus x squared. That's why when we did our small case, 1 minus 2 squared gave me 1, but so did 2 minus 1 squared. And so I got to count those. That's and when we count our possibilities, we're going to multiply. So it'll be 6 times 2 times something. And then, so we've got these 6 squares. Once we choose a pair, so once we choose our x and our y, so for example, say we come along, we say, all right, we'll be using 2 and 12, and we say we're going to add up we're going to count how many times 2 and 12 appear here, or 2 minus 12 squared appears here. So it could be 2 minus 12, or it could be 12 minus 2. But then, what other factors are there left for us to choose? Well, we get to choose this A, and this D, and this E, and this F, and this G, because all we're counting up is the number of ways we get 2 minus 12, or 10 squared here. So 5 other letters to assign. And that can be done in 5 factorial ways. Okay. So, if I can figure out the sum, write this. I'm not going to write the whole sum out, but I'll show you how you might start making a little chart for it. And then so I get that sum, I multiply by 6 times 2 times 5 factorial, which I guess 6 times 5 factorial is 6 factorial. So it'll be 2 times 6 factorial over 7 factorial, because that's the number of ways to rearrange them. Except 7 factorial can be written as 7 times 6 factorial, so those guys actually cancel out. So it'll be times 2 over 7. So multiply that by 2. So now I just need to figure out this big sum. And I don't think there's really a fancy way to do it, so I'm just going to grab my calculator here. Okay. You guys can watch me do this, I guess. So I'll call it out as I do it. 14 minus 13 is 1, so we'll get 1 squared, 2 squared, 3 squared, 11 squared, 12 squared, 13 squared. So that's the first row. That's 448. I'm actually going to write this down just in case I have problems and I miss a button press or something like that. It'd be helpful. You don't want to screw it up at the last second. That said, if you're racing to finish this question because time's running out, don't bother with little things like that. But no, absolutely write it down if it's a long computation. So 13 minus 12, that'll be 1 squared. And then 13 minus 11 is 2 squared. 13 minus 2, 10 squared. 11 squared. 12 squared. So this next row is 370. And now the row that starts with 12. 12 minus 11 squared, so that's 1 squared. Plus 9 squared. Plus 10 squared. Plus 11 squared. We'll go to 303. Now the row that starts with 11, so it'll just start with 11 minus 3, so that's 8 squared, plus 9 squared, plus 10 squared, 245. Now we'll start with 3, so 3 minus 2 is 1 squared, plus 2 squared, and that'll be 5, and then my final row, 2 minus 1 is 1. Alright, let's add these up, and multiply by 2 over 7, and hopefully we will get an answer that is in the list of possibilities. So multiply by 2, divide by 7, and I'm getting a final answer of 392. For those of you wondering, I think it was 1372. Let me just reverse the calculation. Multiply by 7, divide by 2. Yeah, 1372 as the sum of the rows. 392, I think we were in the late 300s. Yeah, there it is. It's D. So D will be our final answer. Yeah, so I used a fair bit of sort of fast counting with factorials in this and understanding rearrangements. These are themes that come up, and so it's important to learn them if you haven't already. But more than that, I would say probably the biggest takeaway from this question is how I started it off with looking at a smaller case, 1, 2, and 5. You might have done another like 4-thing case just to really double check. But then after that, it was all reasoning. You know, okay, I want to make these choices. What other choices can I make? And remember that we multiply if you say, I do this choice and this choice. And you add if you say this choice or this choice. Yeah, I don't think I have anything left to say. It was kind of an easy Cayley, to be honest. I mean, you may not have thought that. Maybe it's just all questions that I found easy. But, yeah, it was a good Cayley. So my next multiple choice contest will be the 2008 Fermat. If you're looking for another grade 10 level contest, you can try some of my past Cayleys. Of course, next week I'll be putting out the 2008 Galois paper. So feel free to stay tuned for that. Subscribe so you get the notification when I put that out. But other than that, have yourselves a wonderful day. I'll see you around.